Good evening. Today we are going to study simultaneous equations. So now we have simultaneous equations. Let us say a1x1 plus b1x2 equal to c1, a2x1 plus b2x2 equal to c2. And then we have in this unique solution for these equations when we have a1 upon a2 is not equal to b1 upon b2. Means if we will consider two lines and if these two are going to intersect only at one point, then we are going to say this is unique solution. And that will be possible when we have a1 upon a2 is not equal to b1 upon b2. Then we have no solution, and that is possible when we have a1 upon a2 equal to b1 upon b2, but it is not equal to c1 upon c2. And then in that case, we have these two lines. If we will consider two lines, then we have these two lines are parallel, and therefore we do not have any solution for this. So no solution. And third, we have when all are equal, then we are going to say many solution, and that will be the case when two lines overlap each other for some portion. And in that case, we have many solutions for this. So we have these are the different solutions. Now, when we have these two, then we are going to say that equations are consistent. And when we have no solution, then we are going to say equations are inconsistent. So when we have unique solution or we have many solution or we are going to say infinite solution, then we are going to say set of equations are consistent. And when we do not have any solution for that set of equation, we are going to say it as inconsistent. And accordingly, we have to go for the problems of this simultaneous equation. So we are here going to cover around problems which are from last 20 years. So now we have first that is consider the system of equations and find the value of x3. So was asked in 2020 and we have these equations x1 plus 3x2 plus 2x3 equal to 1, 2x1 plus 2x2 minus 3x3 1, 4x1 plus 4x2 minus 6x3 2, and 2x1 plus 5x2 plus 2x3 equal to 1. Then we are going to be equation form that is a, b. Here we have that is coefficients of unknowns and b that we have constant. And then we have these equations. You can see this. So these are the coefficients of x1, x2, x3, 1, 3, 2, 2, 2 minus 3, and 4, 4 minus 6, 2, 5, 2. And then we have 2, 5, 2. And then these are constant, which are 1, 1, 2, 1. And these are unknowns. So we have this will be equal. Now we are going to make actually lower triangle 0. So now in that one, or we have to make one of the row in such a way that where I have these two coefficients are 0. Now you can see we have this row and this row. If I will multiply this row by -2, automatically this row becomes 0. So we will go with that operation first. You can see this. So we have this will be, and here we have made that is R3 that is equal to R3 minus 2R2. And from this, we have these all are 0. So this row is of no use now. Now we are going to make that is equations in such a fashion we should have only x3. And we are going to make this now next operation. You can see this. We have next operation that is this made 0 and this we have made 0 because we are going to make lower triangle 0. Now this we do not have. So now instead of lower triangle, or we can have this 0 and we have this 0. So automatically we will get this value relate with x3. So now in this we are going to get, if you will shift this that is next row, then automatically you are going to make it as upper triangle 0. So now here I have made that is R2 and that is equal to R2 and we have made this 0 that is R2 minus 2R1. So minus 2 into 1 plus 2 becomes 0. Minus 2 into 3 minus 6 plus 2 becomes minus 4. Minus 2 into 2 minus 6 sorry, minus 2 into 2, minus 4, minus 3, minus 7, minus 2 into 1, minus 2 plus 1, minus 1. And then now we will make this 0, and this how we will make 0. We will multiply R4. Sorry, this will be right. Then we will go with that last operation where we will make this 0. So we have that is R2 is equal to R2 minus 4R4. And then from this we are going to get this 0. You can have this in this fashion also. So we have 1, 3, 2, and then we have this as 1. Then we have, I will shift this fourth row as a second, minus 1, minus 2, then we have minus 1, and this I will shift below 0, minus 4, minus 7, minus 1. And then last is 0. This, so I will not consider, need not require to consider also, or you can write if you want, then this will be 0. Now we are going to make upper triangle 0, and therefore we have to make this 0. And by using this, you can have that R3 that is equal to R3 minus 4R2. And then automatically you are going to get this. If we will go through this 1, 3, 2, then we have this will be 1, 0, minus 1, minus 2, minus 1, and then this becomes 0. Then we have this will be, so first is 0, this becomes 0 now. Then minus 4, minus 2 becomes plus 8, minus 7, this will be 1, minus 1, minus 4, 4, minus 1 becomes 3. And then you can have directly x3 equal to 3, because we are going to be with this. And then if we will write again in this form, that is 1, 3, 2, 0, minus 1, minus 2, 0, 0, 1. And then we have this will be x1, x2, x3, and then that is equal to now 1 minus 1, 3. And from this we will get this 0x1, 0x2, x3 equal to 3. And we have this value of x3 that is equal to 3. Now we have to consider this system is consistent, and that we have already know. If we are going to consider this matrix A, which are of coefficient B, we have constant, rank of A is equal to rank of B, then we have equations are consistent. And if rank of A is not equal to rank of B, then we do not have equation consistent. And in that case, we do not have any solution for that set of equations. Then we have x plus 2y minus 3z equal to A. Then 2x plus 3y plus 3z equal to B. And then 5x plus 9y minus 6z equal to C. And we will write it in terms of AB form. Now we are going to be with next first operation we are going to make, that is R2 we are going to consider, and here we have R2 that is equal to R2 minus 2R1. And simultaneously we are going R3 equal to R3 minus 5R1. We are again making upper triangle 0. And while making upper triangle 0 means our aim is to make this 0, and this 0. So first we have this 0, and similarly we have this 0 also. Then we have B minus 2A, because we have minus 2R1, and then C minus 5A, because we have R3 minus 5R1. So we have like this. Now we have to make this 0. So we will add this row. So that is next operation we have, that is R3 that is equal to R3 plus R2. And in that case, we are going to get this all 0. And then if our equations are consistent, then we have this will be my A matrix. And this is my B matrix, and rank of A and B should be same for consistent, and therefore we should have this value 0, and therefore we have C minus 3A minus B equal to 0, and automatically we will get 3A plus B minus C equal to 0. And this, if this equation satisfies by ABC, then we are going to say these equations are consistent. Then we have for what value of P, and now we know no solution. And then we have seen that we have A1 upon B1 is equal to, sorry, A1 upon A2 equal to B1 upon B2 should not be equal to C1 upon C2 for no solution. And then we have made over here, that is for no solution, and from this we are going to get value of P 4.5, because here we will get 2P is equal to 9. And likewise we can find this value of P. Then consider the following set of equation. This system is consistent. Now in the same way we have, and then we are going to in the same fashion. Now we will just go for this. Again we have to make, that is upper triangle 0, and then we have to make all this 0, and then you can see we have accordingly go for this operation. So here we have, that is R2 is equal to R2 minus R1, and here we have, that is R3 equal to R3 minus R1, and from this we are going to get these values, and then we have to make this 0, so we can have R3 equal to R3 minus 2R2, and then from this we are going to get this value as 0. You can see this. So this operation here we have, that is R3, that is equal to R3 minus 3R2. So 3 2s are 6, 1 already is there, minus 7. Now we have this consistent, means we have rank of this matrix, and rank of this matrix should be same. Now as we have 0 over here, means we should have 0 over here, then only we have rank of this will be 2 and of this also 2, and therefore we have k minus 7 is equal to 0, and we have k is equal to 7. Then for what value of alpha and beta, following simultaneous equation have infinite solutions. Now infinite solutions means we have a1 upon all r we have same. Now here if we will go, then rank of A that should be equal to rank of B, then only we can have consistent, and consistent we have infinite solution or unique solution. So now we have this equation x plus y plus z, then x plus 3y plus 3z equal to 9, and x plus 2y plus alpha z equal to beta, and then we have with these values. Now here we are going to be with, first we have that 1 1 1, so made over here also. So we have 1 1 1, then lower triangle 0. Our aim is this and this 0. So now first we are going to be R2, that is equal to R2 minus R1, and R3 is also equal to R3 minus R1. So 1 minus 1 0, 3 minus 1 2, 3 minus 1 2, 9, 9 minus 5 4. So 1 minus 1 0, 2 minus 1 1, and then alpha minus 1, beta minus 5. Now make this 0. So for this one I will divide this by 2, and then we will subtract this. So you can have this, first I have divided this as by 2, and now we will go with, that is R3 equal to R3 minus R2, and from this we will get, that is 0. Then we have actually this will be 0, 1 minus 1 0. Then we have this will be alpha minus 1, and this 1, so alpha minus 2, and then alpha minus 5. Now this becomes 2, so alpha minus 7. So we have subtracted these values from these values. R3 equal to R3 minus R2, but actually I have considered R2 this one, and therefore we will get this. Now we have infinite solution if it is consistent, and when it will be consistent, when we have rank will be same. Now we will consider rank of this, that is 2, so we should have alpha minus 2 0, and rank of this also 2, then we have beta minus 7 0, and considering these two, we are going to get value of alpha, and we are going to get value of beta as 2 and 7. And then we have, this problem was asked 2006. So solution for the system defined by the set of equation. Now we are going to be again in the same way. So we have this 0 4 3 2 0 minus 1, because equations, if I will write 0x plus 4y plus 3z equal to 8, 2x minus 0y minus z, 0y minus plus, it's okay, equal to 2, and then 3x plus 2y plus 0z equal to 5. And then we have in this fashion, so we have this value 0, and then 8 to 5. Then again our aim, we have to make this 0, this 0, and this 0. Accordingly we are going to be with this. We have made this 0, so we have this 0 when we have, that is R3, that is equal to R3 minus we have made R2 that is equal to R2 by 2. And therefore this 2 by 2 1, then 0 minus 1 by 2, and this will be 1. And then now we have this R2 actually, so R3 minus 3R2. And therefore minus 3 into 1, so becomes 0. Then minus 3, 0, 0, minus 3, minus 1, plus 3. And this we have 0. So we have plus 3, 3 in minus 3 into minus 1 by 2. It becomes 3 by 2. So this is 3 by 2. And then minus 3 into minus 1. So we have minus 3 plus 5. So we have 2. So we have this will be a equation, and then we will go again one step ahead. So we are going to multiply this R3 equal to R3 plus 3R2. And then if we will multiply this by 3R2, then we have actually we have this becomes 0, and then we have this will be minus 2, and then we are going to say this rank of this matrix and rank of this matrix is not same. And as rank of A is not equal to rank of B, and therefore we are going to say this set of equations we do not have consistent, and it do not have not consistent, and therefore we are going to say no solution. So likewise we have to solve non-existence so we have to solve these problems in this fashion, and this will be about your linear equation. So we will stop here only. Thank you.